Modern enterprise workflows are executing at superhuman speeds. Data is parsed, evaluated, and routed in milliseconds. But the moment that automated workflow requires a payment to continue, the entire system paralyzes. We are leaving the era of passive generative tools, chatbots that wait for a human prompt, and entering a phase dominated by goal-oriented, autonomous agentic networks. These agents can independently query internal databases, deploy code, and analyze live market data without human intervention. The bottleneck occurs at the point of commerce. Traditional financial rails were engineered exclusively for humans. They demand physical identities, social security numbers, and manual two-factor authorization to move capital. True autonomy requires a settlement layer that doesn't demand a government ID to function. This architectural gap points toward a system built on cryptographic proof rather than institutional permission. Software cannot function as an independent economic actor as long as it relies on infrastructure designed for people. An AI agent cannot hold a driver's license. It cannot solve a visual CAPTCHA or visit a bank branch to satisfy Know Your Customer regulations. This table illustrates the mechanical mismatch. Traditional banking carries flat fees as up to 3.5%, settles in days, and requires human approval. By contrast, blockchain ledgers operate on permissionless cryptography, settling algorithmic microtransactions in milliseconds for fractions of a cent. Assigning a cryptographic key pair to an agent provides it with a native, permissionless digital identifier. It replaces the need for a physical identity entirely. This structural reality is driving institutional leaders and major exchanges to actively build non-custodial wallet infrastructure directly into AI developer platforms today. But an autonomous agent cannot rely on highly volatile cryptocurrencies to run stable enterprise operations. It requires dollar-pegged stablecoins to accurately budget for compute and API resources. A cryptographic wallet paired with a stablecoin balance gives an AI agent a functional, volatility-free bank account to use, allowing it to hold and transfer value autonomously. Equipping an agent with a wallet solves the asset problem, but introduces a communication problem. Merchants cannot build custom checkout integrations for thousands of different AI models. The market requires standardized payment protocols. The X402 protocol enables machine-to-machine crypto payments. A server returns a 402 status code. The agent instantly signs a stablecoin transaction, embedding proof in the HTTP header to gain immediate resource access. The server validates and delivers data in one round trip. The alternative is the Agent Payments Protocol, or AP2. Championed by major tech companies, this is a fiat-native framework designed specifically for traditional enterprise commerce. This logic tree shows how AP2 works. Instead of giving an AI unlimited access to a corporate card, it issues scoped tokens encoding strict spending parameters. The system instantly rejects any purchase outside the pre-approved budget or merchant list. While X402 provides friction-free crypto micropayments for raw data and compute, AP2 implements the necessary guardrails to safely integrate AI spending into traditional corporate accounting. The impact of this infrastructure is showing up in institutional portfolios. Asset managers are seeing a shift in how capital is deployed and managed on-chain. This chart reveals exactly how agent behavior diverges from human retail traders. Agent wallets, despite being significantly younger on-chain, hold a wider diversification of assets and process exponentially higher capital inflows to sustain their automated microtransactions. These agents execute complex decentralized finance strategies. They manage liquidity positions and arbitrate decentralized exchanges continuously, operating entirely without human oversight. This dynamic creates the concept of tokenized intelligence. Developers can launch an AI agent and tokenize its revenue streams, allowing the public to trade fractional ownership in its operational success. Investors are shifting their capital. Instead of purchasing static utility tokens to pay for network fees, they are acquiring equity in autonomous digital labor forces capable of generating their own yield. However, transitioning to a completely on-chain agent economy faces massive and potentially fatal technical hurdles. Large language models are probabilistic, not deterministic. They are inherently prone to hallucinations, frequently misinterpreting data or fabricating facts out of thin air. Connecting a hallucinating reasoning engine directly to an immutable blockchain creates severe operational risk. If an agent executes a mistaken smart contract transaction, that capital cannot be reversed or refunded. This formula maps out the solution, a self-reflection loop. Forcing the model to double-check its logic improves accuracy, but multiplies input factors, creating the unreliability tax. Running these multi-turn logic loops causes computational costs to scale quadratically, draining an operational wallet in minutes. Achieving the 95% execution accuracy required for reliable enterprise commerce renders pure, unguided autonomous execution highly expensive and computationally fragile. Beyond the technical flaws, there is a strict legal incompatibility between autonomous code and global financial compliance frameworks. An agent executing thousands of rapid, programmatic multinational transfers will inevitably trigger anti-money laundering alerts. Those false positives lead to instantly frozen accounts and blocked transactions. This exposes a massive blind spot known as the liability void. There is currently zero legal precedent regarding the actions of autonomous financial software. If an agent violates a contract, purchases illegal data, or interacts with a sanctioned entity, the legal system cannot determine fault. Is it the developer who trained the model, the user who deployed it, or the platform hosting the wallet? Until software attains some form of legal personhood, total financial autonomy remains an unacceptable compliance risk for regulated institutions. We're left with a paradox. AI agents must be able to spend money to be useful, but neither rigid fiat networks nor unregulated crypto ledgers offer a flawless solution on their own. This flowchart outlines the most probable outcome, a bifurcated dual-rail economy. Workloads will be routed based strictly on transaction type and regulatory risk. High-frequency, low-value tasks like machine-to-machine data procurement and API access will adopt permissionless blockchains and stablecoins. Conversely, large-scale corporate supply chains and high-value payments will require bounded autonomy. They will utilize fiat-connected mandate protocols, maintaining a human in the loop to satisfy legal compliance. These two financial systems are destined to coexist side by side, supporting the maturation of the AI economy. The emergence of agentic commerce creates a parallel programmatic economic layer. This new infrastructure operates at the speed of software, running alongside the human-centric systems we've used for decades.